Hello friends, welcome back to our channel. So today we'll see one more concept in backtracking, that is a sum of subsets problem. Sum of subset. So we know that a subset, right? So we'll take a set of elements, some x1, x2, x3 and so on, xn, and from this particular set we are supposed to find out the subsets, right? So all the combination of subsets, right? Let it be x1 comma x2 is one subset, x1 comma x3 is another subset, x1 x2 x3 are one subset, and similarly so on. There will be a lot of combinations, right? So here what we have to do is we need to consider a sum, right, which is denoted as m, and we need to form the subsets whose sum is equal to this m, right? For example, let us take 3, 4, 5, 2. So these are the elements in the set. Okay, these are the elements in the set. Now the total sum is 9. So we need to form the subsets where the sum of elements of that particular subset should be equal to 9. So here you can see 3, 4 and 2. So this is a subset of this main set whose sum is equal to 9. Similarly 4 comma 5. 4 comes before, no? So 4 comma 5. This is another subset whose sum is equal to given 9. If m is equal to 8, we need to form the subsets where sum of all the elements of subset must be equal to 8. So it will be 3 comma 5. Any other possibilities, any other solutions? No, there is no solution. So to find these subsets where sum is equal to given total is the problem of this sum of subset problem, and this will be implemented with the help of backtracking. So we have studied about the introduction of backtracking, and also we have seen one example of one application of backtracking, and here we are supposed to find the sum of subsets using a backtracking. So in this backtracking we are supposed to use the brute force. Brute force means checking all possibilities, right? And we need to find out the state space tree. So in this state space tree we will get all the combinations. So some paths may lead to the solution, some paths may not lead to the solution. So all the possible paths which may lead to solution and not solutions will be there in this state space tree. From there we will be getting the solutions, and here we are not finding the optimal solution, but we are finding all the feasible solutions. So here we can see this is not an optimal solution, because optimal solution is only one solution, best solution. So in this backtracking we are not finding the optimal solution, but we are finding all possible solutions. So in this one we can get the two possible solutions, right? Now we'll see the state space tree first, and then we'll write the step by step procedure, right? So we'll take the same example, and I'll draw the state space tree so that you will be getting the solutions, right? So let us consider it as W. So by observing this you may having an idea about the 0-1 knapsack problem. So there also we are taking weights and a profit. So we need to consider the optimal solution by considering less number of weights with a more profit, right? So the same way here we are calling them as elements, and we are simply finding the sum of subsets. So The elements are 3, 4, 5 and 2. And m means a total which must be equal to 9. Yes. Now we are supposed to find the solution. State space tree, right? For example, consider them as x1, x2. So if x is equal to 0, that implies not consider. If x equal to 0, that implies not consider. If x equal to 1, it implies consider. So we need to check each and every possibility for all the elements with inclusion and without the inclusion. That means with consideration and without consideration, we need to find out the state space tree. Right? See, first let us take the sum as 0. Okay, right? 0 subset and weight is 9. Sum is 9. So this is the root. That means subset with 0 elements. Subset with 0 elements. Now, let us consider if you add one element, the first element. For example, let us consider only first element. What is the first element here? I'll write here x1, x2, x3, x4. 4 elements are there. Consider x1. x1 is equal to 1. So if x is equal to 1, we are considering, right? So what is the first element? 3. So 3 will be added into this one, and from the weight we need to reduce the, from the sum we need to reduce the weight. What is the weight? 3. So 9 minus 3, it is 6. So we are considering two arguments. One is a subset, another one is a weight. Now check whether the sum of subset is equal to 9. No, right? So we can again further consider. See, x2 is equal to 1. Always this backtracking will be following the depth first search. Okay, this is most important. Always we need to find in a way that depth first search. So this element we need to find out this element. Now x2 is equal to 1. That means second element should be considered. So now the subset will be having 3, 4. And 4 will be reduced from 6. So it will be 2. Consider 3 plus 4, 7, which is not equal to 9. So it can be further down, right? Again, depth first search. x3 is equal to 1. We can consider x3 also because the sum is less than 9, right? So x3 is 5. So here 3, 4, 5. 5 minus 2 minus 3. You can check the weight goes to the negative. So that implies the sum of subset is greater than the target value. So let it be, this is a target. Sum of subset is greater than the target. So we should not consider this one. So this is not a feasible, right? So not feasible. So what we have to do, we need to backtrack and move with the another direction. So backtrack towards this one and let us consider x3 is equal to 0. That means without considering x3. Without considering x3, so we are moving with 3, 4, 2. The same thing will be appear here. Again, depth first search. Again, you have to go with the depth first search. Now, x4 is equal to 1. Okay, x4 is 2. Consider 3, 4, sorry, we have to consider 2 also. 2 and 2 minus 2, it is 0. You can say that sum of subset 3 plus 4 plus 2, it's 9, and also the target, the total value is 0, that means 9, right? So this is one solution. We got a solution, so we can stop here, and we need to find another possible solutions, right? So we need to find all the possibilities. So backtrack and consider if x4 is equal to 0, then it will be 3 comma 4 comma 2. What is the sum of subset? It is 7. So it can be further executed, right? Further evaluated, but it reaches to the last element. So not feasible. Not feasible. So what we have to do, if it is not feasible, we need to backtrack. So move to the backtrack, and here again there is no position, so again backtrack, and again backtrack, and here you can consider x2 is equal to 0. So previously this path is considering x1, x2 0. Now the path, the elements are 3 and 6. From this again we need to find the depth first search. Consider x3 is equal to 1. Okay, depth first search means left side root. So x3, what is the third element? It is 5. Now 3 comma 5 1. So we need to reduce the weight from the target sum. So 3 plus 5, it is 8. Again still it is less than the target. It can again furtherly divided, right? x4 is equal to 1. So consider x4 3 5, x4 is 2, it is minus 1. You can check the total value, it becomes 10, which is greater than 9. So this is not feasible. This is not feasible. Backtrack and possible position. x4 is equal to 0. Without considering x4, it will be 3 comma 5 1, and this cannot be further divided because x4 is the last element. So this is also not feasible. Again backtrack, this was completed, again backtrack, and here we can consider x3 is equal to 0. x3 equal to 0. x3 is equal to 0 means again we'll get 3 6. So sum of subset 3, which is less than 9, further divided. So again x4 is equal to 1. So 3 comma 2 comma 4. What happens here? Sum of subset is 5. It can't be further divided because this is the last one. So this is not feasible. Similarly backtrack. So without considering x4 is equal to 0, this becomes again 3 comma 6. This is also not feasible. It can't be further divided because this is the last element. Now again backtrack. Check all the possibilities. No, here also there is no possibility. Backtrack, and again it moves to backtrack, and now we are supposed to consider x1 is equal to 0. So this complete path, these are all the possibilities when we consider x1 is equal to 1, and we need to consider the second one, that is x1 is equal to 0, right? So if x1 is equal to 0, the set will be again empty set with a 9, and we need to follow all the same things. So again consider x2 is equal to 1. What is x2? 4. 9 minus 4, it is 5. Sum of subset is less than 9. So further divided. x3 is equal to 1. Let it be 4 comma x3 is 5. Okay, and it will be 0. Right? What happens? 9. 9 becomes 9. So this is one solution. This is one solution. So I'll mark with a double circle, right? This is one more solution, and we need not move further. So backtrack for alternatives. Again, x3 is equal to 0, not considering. So it will be 4, 5. Again, further can be divided. So x4 is equal to 1, 4 comma 2 comma 3. It can't further divide it because x4 is the last element. So 4 plus 2, it says 6, not equal to 9. So this is not feasible. So backtrack and check with the alternative. x4 is equal to 0, and it will be 4 comma 5, which is also not feasible. Now again move with the towards a backward, and here, and consider now x2 is equal to 0. x2 is equal to 0, right? Now what happens? Again empty set with 9. x3 is equal to 1, x3 is 5, 4. So 5, sum of subset is 5, which is less than 9. Further it can be divided. Consider x4 is equal to 1, 2. So then it will be 5 comma 2. So which is not further divided. So it is a not feasible. It's not a feasible. So move towards backtrack and consider x4 is equal to 0, and it will be again 5, 4, which is also not feasible. Right? Again backtrack, and now I'll write here, right? So consider x3 is equal to 0, x3 is equal to 0. x3 is equal to 0 means again it will becomes 9. So again it can be further divided. So x4 is equal to 1, so it becomes 2 comma 7. It's not feasible. Backtrack, again x4 is equal to 0, it will be blank, and 9, which is not feasible, right? So we are having only two possible solutions. One is 3, 4, 2 and 4 comma 5. Okay, manually we have seen all these things, right? Now the solutions will be, what are the solutions? How we can write down the solutions? So one is 3, 4, 2, right? So this can be represented 3 comma 4 comma 2. This can be represented as 1, 1, 0, 1. 4 elements. We are considering the first element, second element, and we are not considering the third element, and again we are considering the fourth element. So 3, 4, 7 plus fourth element 2, total becomes 9. Similarly the second one, it is a 4 comma 5. So this can be represented as 0, 1, 1, 0. So this is not a binary. Okay, don't get confused. This is not a binary representation. So this represents which element should be considered and which element is not to be considered, right? So again this becomes 9. So these two are the solutions of sum of subset problem for a given example, right? So what we are doing, so first we are starting with an empty set. We are inserting or adding one element to the empty set, and we are checking whether the sum of subset is equal to the target sum, and if it is not, or if it is less than, it can be further evaluated. That means again we can add one more element and we can check the total sum with the target sum. And if it is also not equal, if it is equal, then we can stop and we can consider that as a solution. And if it is not equal and it goes beyond the target, then obviously we have to stop and we have to backtrack and we have to select the alternate path. So in this state space tree, you can see we have considered all the possibilities. So some paths are not feasible. So you can check this path is not feasible and this path is not feasible. This path is not feasible. So this state space tree will be having all the paths which leads to the feasible solutions and not feasible solutions. And backtracking is mainly to identify the multiple feasible solutions, not to the best or optimal solution. Right? So hope you understood this one, and practice with a more number of examples so that you can understand and you can get a complete clear-cut idea about this sum of subset problem using backtracking. So let's stop here. Hope you enjoyed the session. If you really enjoyed the session, like my session, share my session with your friends, and don't forget to subscribe to our channel. Thanks for watching. Thank you very much.